Hello students and welcome to Chemistry B. I'm Miss Slate and today we're going to talk about how to do mass-to-mass stoichiometry problems. So here's our example. One of the reactions that inflates airbags in automobiles is the decomposition of sodium azide. During the decomposition, sodium azide breaks down into nitrogen and sodium. Determine the mass of nitrogen produced if 100 grams of sodium azide is decomposed. So this is a little bit different than what we've been doing with stoichiometry because we are going from the mass of one substance, sodium azide, to the mass of a second substance, nitrogen. So let's walk through the steps that we need to go through to solve this problem. The very first thing that we need to do is we need to write the chemical equation and balance it. So sodium azide, they gave us the formula, NaN3, and they tell us it's decomposing into sodium and nitrogen gas, which is diatomic. So then we just balance it. Balancing the equation allows us to determine the mole ratio between the elements, okay? So 2 moles of sodium azide will decompose into 2 moles of sodium and 3 moles of nitrogen, and that's going to be important. But the first thing we need to do is we need to convert our 100 grams of sodium azide to moles. So that's the first thing we're going to do in the calculation. In these problems, it's very important to label what substance you're dealing with. So when we're doing mass-to-mass stoich, you absolutely need to label the substance in your work along with the units. So now that we have moles of sodium azide, because we've canceled our grams, now we need to convert to moles of sodium. So this is where you can flip over to the other side of your mole diagram and look at the expanded mole diagram. Because here's essentially the path that we're taking. We're taking the mass of sodium azide, converting it to moles. Then we're going to use a factor to convert from moles of sodium azide to moles of nitrogen. And then lastly, we will convert to mass of nitrogen. That factor that allows us to convert from one substance to another is the mole ratio from the original equation. So our mole ratio of sodium azide to nitrogen is 2 to 3. So I want to cancel moles of sodium azide. So my 2 moles of sodium azide go on the bottom. Again, with this 2 coming straight from the balanced chemical equation. Then I want moles of nitrogen, so I'll put my 3 moles of nitrogen gas on the top. Again, where the 3 is coming directly from the balanced chemical equation. Now, moles of sodium azide cancel, and then we can just convert from moles of nitrogen to mass of nitrogen. Now, everything's canceled out except for our mass of nitrogen, so we can just pull out our calculator and do the calculation. Rounding to significant figures, we get an answer of 64.64 grams of nitrogen. And like I mentioned before, when we're doing mass-to-mass stoichiometry, you must label the substance, because otherwise this mole ratio in the middle doesn't make any sense. So we must be labeling the substance. Let's look at another example. This one says, calculate the mass of silver chloride that can be produced from 200 grams of aluminum chloride using the equation. And so here they gave us the balanced equation. So again, we're going from the mass of aluminum chloride to moles of aluminum chloride, then use our mole ratio from the equation to get to moles of silver chloride, and then lastly, converting to mass of silver chloride. Once again, now that I have moles of aluminum chloride, now we're going to use the mole ratio from the balanced chemical equation to convert from aluminum chloride to silver chloride. Looking at the balanced chemical equation, our ratio of aluminum chloride to silver chloride is 1 to 3. So I'm going to put 1 mole of aluminum chloride on the bottom to make moles of aluminum chloride cancel, and then 3 moles of silver chloride on the top. Moles of aluminum chloride cancel, and now I can convert from moles of silver chloride to mass of silver chloride, just like normal. Then we just need to do our calculation. So 200 grams of aluminum chloride divided by 133.341 grams of aluminum chloride times 3 moles times 143.321, which, rounding to 4 significant figures, is 644.9 grams of silver chloride. Lastly, let's look at one where it's not just straight mass to mass, but instead we're going mass to volume in this case. So for this question, it says how many grams of sucrose are produced from 115 cubic decimeters of carbon dioxide. So with our mole diagram in this case, we are going from volume of carbon dioxide to moles, using our mole ratio to convert from moles of carbon dioxide to moles of sucrose, and then converting to mass of sucrose. Now that we have moles of carbon dioxide, we're going to use the mole ratio from the chemical equation. So we've got a ratio of 12 moles of carbon dioxide to just 1 mole of sucrose. Now that we've got moles of sucrose, we're just going to convert to mass using the molar mass. Our final answer comes out to 146 grams of sucrose. And so you can see how we can use the expanded mole diagram and the mole ratio from a balanced chemical equation to go from either volume, mass, or particles of one substance to volume, mass, or particles of another substance in an equation. And that concludes our notes on mass-to-mass stoichiometry.